Hello students, this is the third video of chapter 4 and it presents on writing chemical equations for ionic reactions. The learning goals of this video is writing chemical equations in molecular, total ionic, net ionic formats and identifying the spectator ions. So what is a molecular equation, the total or complete equation, the net equation, and how can we identify the spectator ions? I am going to explain this, and there are some steps that we follow to write the chemical equation for all of these three, and I will elaborate this with examples, and finally I will give you an activity to be done by yourself. So what is molecular equation? Molecular equation is an equation that shows all substances intact and undissociated into ions, including the spectator ions. And this molecular equation is written as a molecular substance that describes the actual reactants and products. It does not give any information about what is happening at the level of the ions, whereas the total or complete or dissociated equation is an equation that shows all the soluble ionic substances dissociated or separated into solvated ions, and it includes also spectator ions like the molecular equation, and it is more correct method of writing chemical equation. The net ionic equation is an equation that shows only the actual chemical change at an ionic level, and it is written without spectator ion, that is, it eliminates the spectator ions. So from this, what can you identify is, or how can you identify is, the molecular equation is an equation that includes all the undissociated ion undissociated molecules, including spectator ion, whereas the total or complete or dissociated equation is an equation that shows all the ions, all the substance in ionic or dissociated form, including spectator ions like the molecular equation. But the net ionic equation is an equation that shows only the actual chemical change at ionic level without including the spectator ion. What is spectator ion? The spectator ion is an ion or a species that do not involve or take part in the actual chemical change on the both sides of the equation. It can be cancelled on both sides to express the essential reactions that occurs and not appeared in net ionic equation. There are some steps that we follow to write the above three equations. Step one is writing the balanced molecular equation. If the given molecular equation is not balanced, try to balance that molecular equation first. Second, write balanced complete ionic equation. Third, cancel out the spectator ions. And what remains is the net ionic equation. Example 1. As you can see from here, this is undissociated one. So if it is undissociated equation, that equation is considered as the molecular equation. Check whether this molecular equation is balanced or not. Here we have 1 calcium, 2 chlorine, and 2 chlorine, 2 silver, and 2 silver, 1 nitrate ion, 2 nitrate ions. Here we have 2 nitrate ions. So all the atoms and the ions present in this chemical reaction is balanced. The second one is, how can we write this molecular equation into total or complete ionic equation? Then we are going to dissociate this molecular equation in the ionic form of aqueous, but not for solid. That is, for this aqueous, there is a calcium atom, calcium ion and chlorine ion, so calcium 2 plus and chlorine minus in the aqueous form, plus this is also in the aqueous form, so silver ion plus nitrate ion. Here we have calcium in the aqueous form, calcium ion plus nitrate ion, but this is in the solid form, so it cannot be written in the ionic form. Write it as it is. Another thing is, if there is the same molecules on the reactant side and the product sides, cancel those ions. Here we have calcium ion in the reactant side and calcium ion in the product side, so cancel this calcium ion and this calcium ion. Another similarly, here we have the nitrate ion in the reactant side and the nitrate ion in the reactant side, that they are equal moles with equal moles, so nitrate ion is cancelled also, nitrate ion. After cancelling out the common or the same ions in the reactant side and in the product side, the final reaction becomes 2 mole of chloride ion plus 2 mole of silver ion. It gives 2 silver chloride. This is the net ionic equation. Now the spectator ion is an ion that does not exist in the net ionic equation. So after cancelling out the same ions in the reactant and in the product side, here what is not existing ion here is calcium ion and nitrate ion. So calcium ion and nitrate ions are the spectator ions. This is example 1. Similarly, for example 2, the molecular equation is, this one is the given molecular equation. But if you check this molecular equation, it is unbalanced. So you should first balance the molecular equation. After balancing, the coefficient for sodium hydroxide becomes 2 and the other remains. And then change this to get the total or complete ionic equation. Change those equations or those compounds that exist in aqueous form except some molecules of covalent. Carbon dioxide cannot be written as ionic because this is a covalent compound, so write this as it is. Sodium hydroxide can be written as the ionic form, sodium ion plus hydroxide ion, and then sodium carbonate can be written as sodium ion plus carbonate ion, and water is liquid, so write it as it is. And then to obtain the net ionic equation, cancel out the ions that exist in the reactant side and in the product side with equal amount of moles. So sodium ion will be cancelled by sodium ion, and there is no other ions that exist on the reactant and the product side. So the total or the net ionic equation will be carbon dioxide plus 2 mole of OH ion giving carbonate ion plus H2O. So what is which ion does not exist in the net ionic equation? Only sodium ion does not exist in this equation, so the spectator ion is sodium ion. Example 3, the molecular equation is given here. This is the molecular equation because it is an dissociated one, and check whether this molecular equation is balanced or not. So it is already balanced, and then change this molecular equation into ionic equation. Change those ionic compounds into ionic form, silver ion plus silver nitrate for this, and sodium ion plus chromate ion for this will give, this is written as it is because its physical state is solid, and then write this as an ionic form, sodium ion plus the nitrate ion. And then to get the net ionic equation, cancel the molecules on the reactant side and on the product side. Here we have 2 mole of nitrate ion, and here we have 2 mole of nitrate ion. This nitrate ion will be cancelled by nitrate ion. Similarly, here we have 2 mole of sodium ion and 2 mole of sodium ion. Since they are equal in moles, so this and this are cancelled. Finally, the net ionic equation becomes this. So from this net ionic equation, which ions are not existed in the net ionic equation? As you can see from here, sodium ion and nitrate ion ions are not existed in this net ionic equation. So these two are spectator ions. By visualizing, as you can see from here, silver nitrate, this one is silver nitrate and this one is sodium chromate. After the mixing of, or after reacting of silver nitrate and sodium chromate, it becomes like this. This solid part is silver chromate, and there are some spectator ions that are not reacted, they exist individually. So this is the way of writing these 3 chemical reactions. So this is all about writing chemical reaction. Then I will give you an activity or some activities to be done by yourself. Do these activities by yourself. The first activity is Identify the following chemical equations as molecular, total ionic, and net ionic equation for these three. And the second activity is, for each of the following molecular equations, write total ionic, net ionic equation and identify the spectator ions for these chemical reactions. Thank you for watching today's lesson. Bye bye, see you next time.